titled Function Investigation, and we're going to answer the question, how can I describe a function? We're going to read pages 18 and 19 first, but go ahead and fill in the objective, which says, by the end of the lesson, I will be able to investigate a family of rational functions as evidenced by completing the task in 132. 18 first. 18 up at the top talks about families of functions. So we're going to investigate a function that's going to be in the form y equals 1 over x minus h, okay? And it says, what do all the graphs in that form y equals 1 over x minus h have in common? And what differences do they have? Since each function of the form 1 over x minus h has the same basic relationship, so you're going to discover something about it, between x and y. This set of functions will be called a family of functions. The function y equals 1 over x with h equal to 0 is called the parent function. And in the equation y equals 1 over x minus h, the letter h is called a parameter. It's what's going to change it. It's going to move it or somehow. While x and y are called the variables. What is the difference between a parameter and a variable? And what role do parameters and variables have in a family of functions? Use examples in this lesson to illustrate your understanding of parameters and variables. What other families of functions have you studied in this course or previous? Well, we haven't studied any in this course yet. Or in previous courses, what is the parent function for each family? So after you finish investigating it in the problem that you're going to do in your team, you're going to complete this learning log. It's going to give you like a direction of where you should go with it. I want you to write about 5 sentences down here, which should fit on this side. But if it doesn't fit on this side, it gives you a few extra lines on the next page. You don't necessarily need to write more here if you write small enough and it fit on the first page, okay? And then it goes into asymptotes. So a mathematically clear and complete definition of an asymptote requires some ideas from calculus. But some examples of graphs with asymptotes should help you recognize them when they occur. In the following examples, the dotted lines are the asymptotes, and the equations of the asymptotes are given. In the 2 lower graphs, the y-axis, which is x equals 0, is also an asymptote. So the asymptote is usually drawn in with that dashed line. So in this first one, here's your vertical asymptote at x equals 2, and your horizontal asymptote at y equals 3, okay? This one's a little different because it's not what it's approaching, but it's what all of the points are gathering around. The asymptote y equals 5. Notice the asymptotes are dashed, so they're not confused with like the x-axis and the y-axis. But they did say that in these bottom 2, that the y-axis is also an asymptote. So there is an asymptote right here, but the problem is when you draw it on top of the axis, you're not necessarily seeing it. So if you have 2 different colors, you could kind of do it like right next to it to draw attention to it. This one's curved, so it's your parabola y equals x squared. This one's slanted. Most of your asymptotes are going to be vertical and horizontal, but yes, you can have slanted, you can have curved asymptotes as well, okay? So down at the bottom it says, as you can see in the examples, the asymptotes can be diagonal lines or even curves. However, in this course, asymptotes will always be horizontal or vertical lines. The graph of a function has a horizontal asymptote. If you can trace along the graph out to the left or right, that is, as you choose x values farther and farther away from 0, either toward negative infinity or toward positive infinity. The distance between the graph of the function and the asymptotes gets smaller and smaller. A graph with a vertical asymptote. As you choose x coordinates closer and closer to a certain value from either the left or right or both, the y coordinate gets farther away from 0, either towards infinity or towards negative infinity. Okay? So you guys are going to skip the problem that's on page 16 because we don't need to necessarily do that one together. You guys are going to do the one on page 17. Okay? All right, so question 132 says, what will the graph of the function of x equal 1 over x plus 25 look like? Discuss this question with your team and make a sketch of what you predict the graph will look like. Okay, so you're going to make an educated guess. What do you think the graph's going to look like? I know you're going to be tempted to graph it, but it's going to have you actually graph it down at the bottom. So if it's not the same, that's okay. You're making an educated guess, what we call a prediction up the top. And essentially everybody in your group could have a different prediction, unless you all agree. Oh yeah, we're all going to agree on this, but you may not necessarily. Okay, so all 4 of you could have a different prediction. Then after you've made a prediction, you're going to go down to part B and you're actually going to graph it. If you need help entering the graph into your calculator, I'm more than happy to walk around and help you type it in. You're going to draw it on the graph, scaling it appropriately, and then do what it says. So do you see what you expected to see? Why or why not? Yes, it was exactly like our prediction, or no, we were way off, or we were sort of close, but not really, okay? And then adjust the viewing window if you needed. So in Desmos, you can add plus or minus. If you're on a graphing calculator, I can show you how to zoom in and zoom out. When you see the sketch of the graph on your paper, label the important parts, okay? How close was your prediction? Pretty close, not too close, perfect, okay? And then the 5 questions on here, and then that's it, okay? So